everyone, and thank you for tuning in. Now, to get the most out of this practice test, I suggest that you do one of the following. 1. Download the practice problems, complete them, and then watch the video to check your answer. The other option is that you can pause the video to work each problem before revealing the answer. Now, by watching this video, you're definitely increasing your chances of getting a high score on that final exam. Now, I'm going to go through the material quickly but thoroughly, so if you have to rewind and or fast forward for any reason, please feel free to do so. So let's get started. In Section 6, we will cover complex numbers, quadratic equations, square root property, and completing the square. Number 51. Solve the equation using the quadratic formula. So what is the correct answer? Choice B. Alright, so let's get started solving this equation. The first step to solving an equation using the quadratic formula is to make sure that the equation is in standard form. So notice the equation we were given is not in standard form. Recall standard form is where all your numbers are on the left side and 0 is on the right. So the first step we need to do to get this equation in standard form is to simply add 1 to each side. And now that we have it in standard form, our next step then is to assign values to A, B, and C. Now when the equation is in standard form, the order would be the x squared term first, then x, and then the constant. So the coefficient of the x squared term we call A, the coefficient of the x term we call B, and coefficient of the constant we call C. So next, all we have to do is plug these values into the quadratic formula. So A is 2, B is -4, and C is 1. Here is the quadratic formula, which reminds me of a song I heard. I can't believe they actually made a song about the quadratic formula. The music was by Carlito McFeely Stephen and arranged by Olin Rainbow. And it sounds a little bit something like this.
X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a.
Yes, they actually made a song of it. I mean, that's pretty cool. Anyway, so plugging those values into the quadratic formula, it should look like this. So we can continue simplifying this. -4, but with a negative in front of it, becomes +4. -4 squared is -4 times -4, so that's going to give me 16. Multiplying these three numbers is going to give me -8 all over 4. Next, we have 16. Take away 8, which is 8. 8 is not perfect, but it does have a perfect inside of it, so go ahead and simplify the radical. Next, we want to go ahead and factor out this GCF. There's a GCF here of 2 that these two terms have in common. So let's go ahead and factor that out. Once we factor that out, we can then cancel the common factor there of 2. So take the 2 out of this 4 and cancel that 2 with this. So once we do that, we are left with our answer choice. Number 52. Solve using the square root property. So what is the correct answer? Choice B. Okay, so to solve this equation using the square root property, the first thing we need to do is to use the square root principle to eliminate the square here. because you notice the left side is squared. So to get rid of that squared, you have to do the opposite operation, which is take the square root of that side. Now remember with the rules, whatever you do to one side, you do to the other. So by taking the square root of both sides, we notice that the left side is square root of -9. That equals 3i. So you're going to have x minus 7 equals plus or minus 3i. Remember, we used the plus or minus with the square root property. Last step to solving this is to do what? Yes, add 7 to each side, and x equals 7 plus or minus 3i. Number 53, multiply. So what is the correct answer? Choice C. So note here we are multiplying two binomials, and it doesn't matter that they are complex numbers. Anytime you're multiplying two binomials, you need to use FOIL. First, outer, inner, last. So let's get started with the process. First equals 18, outer, negative 16i, inner, negative 36i, and last, 32i squared. Next, we need to combine outer and inner because outer and inner are like terms. We're also going to note that every time we see I squared, we're going to replace it with -1 because by definition, I squared equals -1. Continue, simplify. So lastly, we need to combine the real numbers. We have positive 18 combined with negative 32, which is going to give me a final answer of negative 14 minus 52i. Number 54, divide. So what is the correct answer? Choice A. So recall when you're dividing complex numbers, you need to use a process called rationalization. And so what that means is you're going to multiply the top and the bottom of this expression by the conjugate of the denominator. So on the denominator, we have 5 plus 8i. The conjugate of 5 plus 8i is 5 minus 8i. So I'm going to go ahead and multiply both the top and bottom by 5 minus 8i. Let's go ahead and begin the process. First, 30. Outer, negative 48i. Inner, negative 15i. Last, plus 24i squared. On the bottom, we have conjugates, so we only need to do the F and the L because remember with conjugates, outer and inner will always cancel. So first gives me 25. Last gives me negative 64i squared. Next, remember by definition, everywhere you see I squared, you're going to replace with -1. We're also going to combine our O and I, outer and inner, because remember, outer and inner are like terms. Continue simplifying. So on top, we need to go ahead and combine the real numbers there. We have 30 and negative 24. That's going to give us 6 minus 63i over 89. Our last problem is on completing the square, but before we begin, I want you to understand how to actually complete the square. So we have this chart here, which makes it very easy to understand. And in the first column, you'll notice we have our x squared term along with our second term, which is our x term. What we're missing there in that complete trinomial, we're missing the last term. So you can actually find that last term by simply using this process. So you look at the x term there, the coefficient of the x term. In this case, the first one, it's 16. So you say, what's half of 16? Well, half of 16 is 8. And then 8 squared would equal 64. So that is the last term that is missing to complete that trinomial. We can go ahead and factor that now, and it factors into x plus 8 squared. Remember the perfect square trinomials when they factor in some binomial squared? So let's try another one. So on the second example, our second term, which is our x term, is 10. So we say, what's half of 10? Half of 10 is 5. 5 squared means 5 times 5, which is 25. And that is the term that is missing. That's the last term to complete that trinomial. And that factors into, you got it, x plus 5 squared. One more. Let's do the last one. Now notice with this one you see x squared minus, the others were plus. Well, that doesn't matter. That's just simply, this is the sign that tells you what sign will go in the binomial once it's factored. But we still need to look at the coefficient here and say, what's half of 6? Half of 6 is 3. 3 squared is 9. So again, we're going to add 9 to that trinomial, which, by the way, perfect square trinomials, the last term is always positive. So we're adding a 9 to complete that trinomial, and that factors into x minus 3. So again, remember, whatever the sign is between the two when it's incomplete, in other words, whatever the middle term sign is, that will determine the sign in factored form. Okay, so now that we have a better understanding of how to complete the square, let's go ahead and actually solve a problem where we're going to need to complete the square. Okay, number 55, our last problem, solved by completing the square. Well, recall the chart you just filled out on the previous slide. So on the first column you have the x squared term, and then you have the followed by the x term. So those were the only terms that were in that first column. That's what we call an incomplete square, and then what you went through the process of finding the number that would complete the trinomial. So the first step then is to isolate those two terms so that you are able to find the number that would complete that trinomial. So to do that, I'm going to add 4 to each side. And so now I have those x terms isolated as they should be. We can proceed by, again, looking at the middle term. So we're just looking at just the 2 and saying, what is half of 2? So half of 2 is 1, and 1 squared still equal 1. So that means we're going to add 1 to that left side. That is what is missing to complete that trinomial. It needed that plus 1. But remember the rules of equations. Whatever you do to one side, you have to also do to the other side. So I'm going to have to also add 1 to the other side. So now I can go ahead and factor the left side, because it now factors into a perfect square trinomial. That factors into x minus 1. And on the right side, when we combine it, that's going to leave us with 5. And so from here, we can proceed with the square root property to solve this problem. Okay, so now we're going to use the square root property to finish this problem up. So remember to remove that squared term on the left side. We need to do the opposite operation, which is to find the square root. So let's find the square root of both sides. Because it's an equation, you have to do it to both sides. So by square rooting both sides, I'm going to have x minus 1 on the left side, and on the right side, I'm going to have plus or minus radical 5. Last step to solving this equation is to add 1 to each side, and I have 1 plus or minus radical 5. Okay, that's it for this lesson. Thank you for watching Math on PowerPoint tutorials. If you liked this video and found it to be helpful in any way, please like it and subscribe to my channel.